Like the amine, the enamine is another hydrolyzable functional group. So to predict the hydrolysis products for this one, what you want to do is find where the nitrogen attaches to the double bond. And that carbon is going to be the carbon we highlight, and that will end up being the carbonyl carbon. And then the bond that gets broken is between that carbon and the nitrogen. So the products that we get, let's break that bond, and we have the nitrogen. It still has the two methyl groups, and it gains a hydrogen. And then we'll draw the other fragment. Here's the carbon that was highlighted in blue. The double bond is no longer present, but what we do get on that carbon is a double bond to an oxygen. So there's a ketone and amine that are the hydrolysis products. For the mechanism, we're going to start with the enamine and introduce it to the proton. And what we'll do is use a lone pair on this nitrogen, and this is going to assist us. Now, you could start just at this double bond and add that to the proton and get a carbocation and draw a resonance structure, which would be valid, but in keeping this with the exact reverse of enamine formation, the exact reverse step of the mechanism we learned before will involve pushing these electrons down, pushing this pi bond over here to grab the hydrogen. I'll go ahead and draw that hydrogen in on this first intermediate. We get a double bond to the N, two methyl groups, and a positive charge. Now you have this activated functional group here that is especially electrophilic, just like an activated carbonyl. Here's where the water will add. The lone pair on the oxygen will add to this carbon and push a pair of electrons up onto the nitrogen. Now we'll draw the structure that forms there. I'm not going to draw in the hydrogen on the end, we'll leave it implied. I have a single bond to the nitrogen with two methyl groups, and the oxygen with two protons on it. So two protons on an oxygen, 3 bonds, that will have a positive charge. From here, now we're going to transfer the proton from the oxygen to the nitrogen, and I'm going to use a lone pair on the nitrogen to do that. So we're going to do the shortcut here for proton transfer. Now I'll end up with the protonated nitrogen and the alcohol. So now that protonated nitrogen is a good leaving group. So what we're going to do from here is use a lone pair on the oxygen, push that down, and assist me in pushing away the amine group. So here I end up with the dimethylamine plus the protonated ketone. And to get to the final product, we can use anything as a base. I can use B, water, I can use the amine, just something to take that proton off of the oxygen to leave us with the neutral ketone.